Ben, it's so good to see you.
It's great to see you too, Rami.
I haven't seen you since our days at Lepanto High School, my friend. What have you been up to?
Well, I became a mining engineer, and I've had a chance to go all around the world to work on different mining projects.
So what brings you back here? Have you had a chance to go around?
Yes, I'm amazed at how much things have improved. I'm back here for the FSC project. How about you, my friend? How have things been?
I'm doing okay. The farming's been quite good.
I noticed you've already got 2 elf trucks outside.
Things have really been looking up. So tell me about your adventures abroad.
I worked on several mines. Remember when Uncle Johnny used to tell us stories about working in a mine? Since then, I've seen new and different ways to do it. It's really quite interesting.
So there are different mining methods?
Yes. It all depends on what the safest and best way to do it is.
I see. So you take careful consideration of many factors.
We do. It involves a very thorough process of studying how we can make the operation safe, how to work with the community, how to maintain or even improve the environment, and of course, make the business profitable. Better mining creates a better future for communities and even countries as a whole.
So what kind of mining was Uncle Johnny involved in?
Uncle Johnny's project was a surface mining operation using a method called open pit mining. Let me show you how that works.
In open pit mining, surface rocks and layers of earth are stripped away using earth-moving equipment. Over time, the mine is made deeper by digging in a series of layers known as benches. Ramps between the benches provide access for trucks and other large vehicles to enter the site. The benches are used for drilling and ore sampling. This is crucial as the miners and geologists must understand the location and extent of the valuable minerals called ore. Open pit mining is used if the ore lies near the surface of the land, or when an underground tunnel type of mine isn't possible. Deposits could be high or low grade. This method usually takes the shape of an inverted cone, with the exact shape of the mine opening dependent on the shape of the ore deposit. The depth of the ore underground determines how wide the pit must be at the surface, as the benches must be built at certain distances to keep the walls stable. Open pit mining creates waste rock, which is rock without the valuable minerals that must be removed to access the ore. This waste rock is stored in waste dumps that are created on the surface next to the open pit. In some instances, these waste dumps can be as big as a pit. It all depends on the size and shape of the mineral deposit. Rehabilitation may involve backfilling the pit or allowing a lake to form and planting on the waste dumps.
So it kind of looks like this?
Generally, yes.
You mentioned that open pit mining is used only when the minerals are relatively close to the surface. How about when they lie much deeper than that?
That's when different methods of underground mining are used.
There are lots of different underground mining methods used throughout the world.
Can you tell me more about these different methods?
Sure. Let me tell you what I have seen in different places. First, there's open stoping. This is usually used for ore bodies that are high grade, narrow, tall, and long. It is best when the ore body has obvious edges, where the ore stops and regular rock starts. The rock in and around the ore should be strong and competent also. To use open stoping, we divide the ore body in blocks called stopes. Tunnels are constructed above and below each stope. The stope is surrounded by pillars of rock, which are deliberately left intact. Some of the pillars could still contain ore, but these are not mined to ensure the mine remains safe. It is common for ore to be left behind. Holes are drilled between the tunnels, and these are carefully filled with explosives. These are then detonated to break the rock, and then the ore can be collected from the bottom tunnel. The first area of mining is generally at the furthest, deepest edge of the stope. Each new area developed is closer to the point of access. Often, each mined area is filled with waste rock or cemented tailings. This is called backfill. As the lowest level is mined and then filled, the level above it can be extracted. This is repeated for each successive level above.
Wow, you've been involved in projects like these?
Yes, in South Africa. That was also where I gained experience in sub-level caving.
Can you explain that to me?
Sub-level caving is the best mining method for large, steeply dipping ore bodies. Engineers usually choose sub-level caving when the ore is lower grade and is spread out over large areas. It is a less expensive mining method where the entire ore body is mined and no pillars are left. The access is generally in rocks that are stable, as tunnels and sub-level drifts must remain open. However, the rocks must still fracture under controlled conditions. As mining removes ore with drill and blast, the waste rock above collapses into the opening using gravity. The ore is extracted via sublevels, spaced at regular intervals in the ore zone. Each sublevel has a systematic layout with tunnels along and across the ore body. It is safe to develop and work in parallel on different sublevels at the same time. This means that continuous excavation works can be ongoing at one sublevel without interfering with another. Generally, sublevel caves are not backfilled, and over time, subsidence will occur. However, to comply with Philippine mining safety law, the surface expression of the cave subsidence has to be filled.
But weren't you just in Australia?
Yes, that's where I came from right before I arrived here. In that particular site, the studies concluded that the most ideal way to mine was block caving. Block caving is a gravity-assisted mining method that is used more and more throughout the world for deposits that are deep and low grade. Usually, the deposit is massive, meaning it has very regular properties and is widespread both vertically and horizontally. Most importantly, the rocks present in the deposit must break into pieces of manageable size. To start mining, we create an undercut opening at the base of the deposit. The overlying ore falls into the opening created. As the broken ore is removed through a series of drawpoint tunnels, more ore breaks and continues to fall into the drawpoints. Mining machinery will go to the drawpoints and remove the ore. Generally, rock will keep falling until the void is filled by the rocks from above. As long as the ore is continually removed from the drawpoints, the caving will progress to the surface. However, to comply with Philippine mining safety law,
The surface expression of the cave subsidence has to be filled.
Wow, mining methods have really come a long way. So I just want to ask, how are you going about the FSE project?
That's why I'm here. Right now, FSGRI is carefully gathering all the information to learn everything we possibly can about the site.
This information will help us choose the best and safest mining method for this project. Better mining means a better future for everyone involved.
Sounds like you'll be here for quite a while, my friend.
That's why I'm hoping we can gather our other childhood friends and have pinikpikan for lunch tomorrow.